Welcome to the launch of Project Innerspace's GeoMap layers for Oceania, bringing harmonized surface and subsurface data layers to support exploration, planning, and development of geothermal energy in the region. By standardizing geothermal potential estimates worldwide, GeoMap empowers governments, researchers, and industry to identify viable locations for electricity generation, direct heat use, and energy storage on a regional to continental scale. The new data for Oceania includes heat flow, thermal gradients, temperature at depth, and heat-in-place volumes, down to 8 kilometres. These maps combine continental-scale modelling with local temperature depth data across Australia, New Zealand, and the Pacific. Where data is dense, they provide high-resolution guidance. In data-sparse regions, they offer a critical first step for exploration. GeoMap shows 1,596 gigawatts of potential in Australia and 100 in New Zealand, nearly 10 times the total current installed power capacity in each country. GeoMap can also assess the overall potential of a region, informing policymakers and developers, and enabling regulatory and policy frameworks and geothermal strategies at the state and national level. Conventional geothermal is already a major energy source in New Zealand, given its position on a tectonic boundary. GeoMap identifies significant new opportunities for next-generation geothermal. Despite lacking New Zealand's volcanic resources, GeoMap data shows Australia is a vast and untapped frontier for geothermal, with opportunities for next-generation geothermal electricity, industrial heat, and cooling. Uniquely, Australia is home to some of the world's largest and hottest sedimentary basins, which hold enormous promise, particularly for direct use and next-generation geothermal systems. The Australian Geothermal Association, which released its latest Australian geothermal titles map, illustrates a keen focus on geothermal in sedimentary basins across the continent. While hot granites like those in the eastern states have received attention in the past, sediment-hosted systems offer a wider application for district cooling, particularly beneath the most populated regions of New South Wales, Queensland, and Victoria. That means the potential for cooling solutions that require significantly less power than traditional options, located directly where they are needed most: cities, industries, and communities. Globally, tech leaders like Google and Meta are turning to geothermal to power and cool data centres as part of a 24/7 carbon-free strategy. GeoMap data shows significant potential for geothermal data centres in the region. An additional use for this data is to identify where current sources of emissions are and whether they sit on any heat resource. GeoMap Australia identifies large industrial facilities and coal plants and identifies where they could be retrofitted for geothermal. Oceania's rich wind and solar often sit above geology suited for underground energy storage. Geo-energy storage can bank the excess and return it on demand, turning variable generation into firm, dispatchable power and boost grid resilience. We invite researchers, energy developers, policymakers and communities to explore the new Oceania geothermal layers and use them to identify opportunities and shape pilot projects. Let's work together to unlock Australia and New Zealand's next-generation geothermal potential.